welcome to my YouTube channel. Today I am going to solve the steam nozzle problem by the help of the steam table method. So what is questions given here? Dry saturated steam at a pressure of 8 bar enters convergent-divergent nozzle and leaves at a pressure of 1.5 bar. If flow is isentropic means entropy will be the constant. Then expansion index they given 1.135. They are asking find the ratio of the cross section area of the exit by throat, that means A3 by A2. So what is the given here? Convergent divergent nozzle. So first we will draw this convergent divergent nozzle. So mass flow rate will be same. So this is conditions 1, 2, this is throat, this is the exit. So P1 V1, here P2 V2, this is known as throat. This is exit P3, B3. So they are asking area of the cross sections of exit by area of the cross sections of the throat. So given here P1. So once they given dry saturated steam, so directly from the steam table we will take the value of the, see the steam tables they given saturated water and steam. That means saturated pressure, enthalpy, specific enthalpy, specific volume, everything will take the directly from the steam table. So here P1 they given 8 bar. From the steam table here H1 directly we can take from the steam table. 8 bar they given 2767.4. Value is 2767.4. Value is there in the steam table directly. Unit will be the kilojoule per kg. So unit will be kilojoule per kg. I am not writing here, it is space problem. So already unit given. Now how this coming? Actually if you see here H1 is equal to Hg1 plus X1 HFG1. That formula also will be there in the steam table. Suppose your university exam writing here, so steam table formula will be there here one itself. Very first page. If you look here, first page, all the formula will be here. See here the given HF plus HFG. So you can get the idea from HF plus HFG, entropy, SF plus SFG. So based on this we can elaborate it. So here dry saturated conditions means X1 equal to 1. So that means Hg plus HFG is HF plus HF equal to Hg. Enthalpy of the fluid, enthalpy of the latent heat, both will add, it will come Hg. That means total enthalpy of the gas or enthalpy of the steam. So that is value this nothing but also known as Hg1. So this is the value. Now what we have to do? We need the H1, H2 and H3. So again H2 formula will be H2 similar. See this H2 means Hg2 plus X2 plus into HFG2. So this all Hg2, HFG2 value will take from the steam table. But here H2 and X2 both will be the unknown. So one more formula we have to use, the entropy formula. So before this what is the given here? The flow is isentropic. That means entropy will be constant. That means S1 equal to S2 equal to S3. Suppose entropy denoting S. So entropy will be equal. Then we'll write one other formula. What is S2 is equal to SF2 plus X2 HFG2. Then we need the S1 value. So S1 value at 8 bar. S1 value at 8 bar. So I'm writing here SG1. That means at 8 bar. 8 bar. What is the value from the steam table? I will take the S1 value. So 6.660. So this value is just 6.660. This will be the kilojoule per kg degree Kelvin. This unit will be there in the always steam table. So unit no need to think. See kilojoule per kg in specific enthalpy, SF, SFG and SG. So if these two will add, SG will come. If HF plus HFG you will add, Hg will be the enthalpy of the fluid, that will be water, enthalpy of the latent heat, that is enthalpy of the evaporation, and enthalpy of the steam. So we have to take the enthalpy of the steam. So from there, SF2 and SG2, this value will take from the steam table. So now what I'm going to write here, we'll take the value somewhere here. All the value will take here. First HF2 at, because the given now here, index number the given, and the conditions maximum discharge. What is the formula for this? P2 by P1 is equal to 2 by n plus 1, n by n minus 1. P2, P1 value is substitute, it will substitute now, P2 value will come 4.6 approximately. And then P3 already given 1.5 bar, P3. So at 4.6 bar, HF2 value will take the steam table, HFG2, SF2, SFG2, all the value will take from the steam table. So what will be the value? Already I wrote, I will write now, HF2 and so SF2 1.829, then HF2 SF2G, that value will be 5.018, then HF2 and HF2. So HF2 value 267.7, then HFG2 2117.2. This all value will take from the steam table. All value will taken from the steam table. Now what we'll do? Now we'll substitute all the value from here. So S1 equal to S2. So S1 is equal to what is? 6.660 is equal to SF2 1.829 X2 plus X2 into SFG2 5.018. So from here we will get the X2. From here we will get the value of X2, that is called dryness fractions of the throat. So X2 value will be there. Already we calculated, X2 value is coming 0.963. 0.963. This is the dryness fractions of throat. I got this value. Now we'll substitute the X2 value. I will substitute the X2 value in equations 1 you give. Anywhere equations given? No. So equation 1. So here I write substitute X2 in equation 1. So what is equation 1 here? So H2 is equal to HF2. This value is HF1 plus X1 HFG1 fluid. HF plus SFG1, this I wrote here. That is called H1. So here also same thing. HF2, enthalpy of the fluid. So H2 is equal to enthalpy of the fluid. What is? 267.7 plus X2 0.963 into HFG2 2117.2. So from here you will get the H2. So we'll get the H2 value, how much we calculated. So we calculated the H2 value here already. So H2 value where we have 2665. Where we saw H2 value will be 266.56. This will be the kilojoule per kg. So H2 value we know now. Now similarly we'll go the Vg2 value. So this is the specific volume value. This is nothing but Vg2 into X2. So Vg2 value will take from the steam table. So what is Vg2 value from the steam table? at 4.6 bar. So VG2 value, we will write VG2 value will be 0.40526. 0.40526. This is the VG2 value. So we will write here 0.40526 into X2. X2 will be 0.963. So this value will come here. If we will multiply, this value will come, VG2 value will come, V2 will be 0.390, 0.390. This value is coming here. So this is V2 value, specific volume value we know now. 0.40526. .390. So getting the value of 0.390. Okay, now we'll go the H3. Similar formula we'll use here. H3 is equal to HF3 plus X3 HFG3. This will give equations number 2. Now, what we have to do? We have to write the value again. What is S2? So here we will write HF3, HFG3, SF3, SFG3 and VG3. All value will take from at 1.5 bar. All value will write. Then we'll substitute this value, entropy, then we'll get the another answer. So what is the HF3? 461.1. HFG3 222 6.3. SF3 1.433. All value we are taking from the Steam table, 5.790. Then VG3 1.159. All value we taken. Now what we'll do here? We know that S1, so S3 is equal to now, because it taken here now S2 is equal to SF3. So SF3 plus X3 SFG3. This formula we are using for the getting the dryness fractions at the exit. So S3 is equal to S1. What is S1? 6.660. 6.60 value is there, 6.660. SF3 1.433 plus X3 we need, then SFG3 5.790. So this here subtract, this will divide, you will get the X3 value, that is called dryness fraction of the exit. So we will get the X3 value here. So X3 value getting from 0.903. X3 value we got here 0.903. So here H1 directly we taken from the Steam table, H2 we calculated here, substituting the X2 value. Now substitute the X3 value in the equation. Substitute X3 value in equation 2. So we'll give there here H3 is equal to HF3 467.1 plus X3 0.903, then SFG3 2226.3. So here we will get the H3 enthalpy of the exit. So enthalpy of the exit value will be 2476.92 kilojoule per kg. So we know all the H1, H2, H3 value, X2, X3 value. And now V3 value, specific volume at the exit is equal to nothing but VG2 into X3. VG3 into X3. VG3 1.159 into 903. This value will come, B3 value will come 1.0466 meter cube per kg. So this value we got, all the value we got here. Now we know the mass flow rate will be same. So A2 V2 by this is volume, steam velocity, then specific volume equal to A3 V3 by V3. So we can write here from there A3 by A2 they are asking. A3 by A2 nothing but A3 by A2. So V2 into V3 is specific volume, then V2 is specific volume and V3. So this we have to substitute all the value. Now mass flow rate A3 by A2 is equal to, what is V2 we got? 451. Oh, V2 we have to calculate. So for this, what we have to calculate? V2 is equal to 44.72 H1 minus H2. So if you substitute all the value, V2 you will get here, we calculated somewhere, yes, 451.343 meter per second. Similarly, V3 is equal to same formula. Value I am not writing, so value you substitute H3, H1 minus H3. So you will get here 762.184 meter per second. Now this substitute value in mass flow rate. So what is there here? A3 by A2 is equal to V2. V2 now 451.43 into specific volume of V3. Specific volume of V3 here 1.0466 divided by V2, specific volume of 2. Specific volume of 2 here, what is 0.390 into V3. V3 will be 762.184. So this value approximately you will get, it will substitute 1.76. So this is the question they are asking, 1.76. So check it once again. So H1 directly from the steam table, H2 we got from the formula, then H3 we got from the formula. For this we have to calculate the S2, SF2 plus SFG2, get S2. Similarly here, similar track, then H3. Now you substitute the value of the mass flow rate. They are asking the ratio A3 by A2, so we got this is the answer. So okay, so like these questions, if you have a steam table, you can solve easily. So watch this video, see the steps one by one and solve these questions. Okay, okay, friends, thank you.